Hello guys, now let us see how can we solve these kind of questions. Again, it's an organic chemistry question. Let's say we are given this kind of structure which has double bond O at two positions, and the reaction is being done in presence of a dilute OH minus. Now let us analyze the aspects of mechanism first of all. So as we know from the mechanism point of view, it is very clear that in such question OH minus is acting as a base. What it can do, it can try to take some hydrogen. So let us see the availability of hydrogen. Can I say H is present here, similarly at this position, even it is present at these positions, and no doubt it is present symmetrically opposite side this way. Now the question that comes to our mind is which particular hydrogen we are supposed to pick, or which particular hydrogen should we take first, right? So let's say we talk about this hydrogen, call it and give some name. Let's say for example A. This one is A. So the right side also is A because they are symmetrical, similar. This is case B and this is also case B. So in the current scenario, we have two options. Either it can be A or it can be B. A or B. Now we don't know. Which one should we start off? Now, the first learning here is that dilute OH minus as a base will go and grab hydrogen. Number one. Number two, it will go and grab hydrogen from alpha position of the C double bond O, which could be position A or position B. So we don't know that part, right? Now let us take that, okay, for example, we are assuming it is position A. If you take from position A, see the result will be like this. It becomes, these H are given, this is double bond O, and the structure is given to us, and again this is CH3. So what can happen? When OH minus comes, take this hydrogen, you can form a double bond, convert it into O minus, which is basically called enolate ion. So there's a name for it, it is enolate ion. The term comes from enol, right? We call it enolate ion. After this enolate ion, what will happen? This enolate ion which you have formed will be like CH2 double bond O minus, and all these things will be as it is. So count number of carbons carefully, that's very important here. This is double bond O and this is CH3. Now this O minus with the help of this CH2 can attack on this C double bond O, and this mechanism is part of addition nucleophilic type mechanism. Now addition nucleophilic is a mechanism in which a nucleophile attacks on C double bond O in this kind of environment. So what is the expectation of this? Can I say we can expect how many carbons? Let us count 1, 2, 3, 4, 5, 6, 7 member. We can expect a 7-membered ring along with these groups which we have discussed. But there's a problem. Because we have a better option than 7-membered, so we need to cross check whether this option is correct or it is wrong option. So if you observe it carefully, the position of double bond O is somewhere here, and it is nothing but beta-hydroxy. So when you provide it, the water that it has left in previous case, it will grab H and release OH minus. So what is this particular structure? It is nothing but beta-hydroxy carbonyl compound, and any beta-hydroxy carbonyl compound is example under aldol. So now let us say, if we go back and check this example, we have understood one thing, that we are getting 7-membered ring. Is there any option that we can get 5-membered ring? Yes, it is there. So what are you supposed to do for that? we can take attack happening at this particular position. So let me take some other color, right? Let's say for example, it happens through this position and it happens to 1, 2, 3, 4, 5 as in this position. So in such scenario, we can expect an answer which is a better answer or which is a correct answer. And if you want to check what is that answer, so we can say this is 1 member, 2 member, 3, 4, 5 member. So can I say I can write here maybe 5 member ring. On the portion where you have drawn the last part, this is O minus. At the same place we have CH3 attached. Next to the joining link of that O minus and CH3 thing, next to that carbon, we should have attachment of C double bond O CH3. Now try to observe, if you say C double bond O CH3, this position, if you talk about this position, it is alpha position, it is beta position, again the same thing will happen. It's a beta-hydroxy carbonyl compound. So later after H exchange, this position becomes OH. And can we also predict that yes, if required later, this part can get a double bond because OH and H will come out to form alpha beta unsaturated carbonyl compound.